Assalamu alaikum everyone. Welcome to the online course of Power System 3. I am Hina and I'll be teaching you Power System 3 in this semester. Today our topic is load flows. In this chapter, we'll be studying about the various load flow analysis techniques. We'll get to know what actually load flow analysis is. We will learn about the different types of buses that are available in the network and how to apply different methods to solve those network equations. For today's lecture, we'll be dealing with the load flow analysis, that we'll understand what actually the concept of load flow analysis is, and after that we will study what are the different types of buses that are used in the power system. So let's start with the introduction of load flow analysis. Load flow is also known as the power flow. By the term load flow analysis, we actually mean analyzing any power system in the normal steady state conditions. After analyzing any power system, we'll get the information about the four basic quantities, that is power, active power or reactive power, voltage and phase angle. So we get the solution of the network using the power flow analysis. But the system may be subject to certain inequality constraints. For example, there will be different voltages under which the system operates, or the active or reactive power of the generators, or the tap settings of the transformers, which may bring some changes in the overall system. Now, what do we actually do in load flow analysis? For example, we have a two-bus system, the simplest two-bus system. If we want to handle that system or to get information about that system, we just have to know the voltage or power, and then we can get any information about that system. But if we will talk about a power system in general, a network of power system, we will not encounter only a system that comprises of two buses. We will encounter the systems that may have many transmission lines in it, that may have many generators in it. So we will deal with a number of voltages, a number of phase angles, a number of currents. So we cannot simply apply the KVL or KCL to get the information about power or current or voltages. So to analyze such systems in which we have a number of transmission lines or we have a number of buses, we use the load flow. Now, we all are familiar that if we have just one equation, we can just simply solve that equation. But when we have a number of equations, we deal with those systems using the matrices. To analyze such systems in which we have number of equations, we use the matrices method. Similarly, in load flow analysis, we have a system which comprises of many equations in terms of power, in terms of voltage, in terms of phase angle. So to deal with such systems, we use the matrix method to analyze the system using the load flow analysis method. For example, if we connect or remove a transmission line, obviously connecting or removing a transmission line will definitely affect a power system. So to analyze the effect of this removing or adding of a transmission line, we will use the power flow analysis method, in which we will represent the system in terms of matrix. After that, if we have to know about the stability of the system, we will analyze the impedance matrix. Or if we want to know about the faults in the system, then we will use the Z bus matrix. So what I want to say is, in load flow analysis, we actually deal with the system using the matrices. We make a matrix, then we solve that matrix, and after that we get the required solution. Now, coming to the importance of load flow analysis. We are now all familiar with the fact that after performing the load flow analysis, we'll get all the information about the system in terms of its active power, reactive power, voltages, phase angles, and whatnot. So this in itself is a big achievement. We just have to play with these and we will get whatever we want to get from it. For example, if we consider a generating station, by using the power flow analysis, we got information about the power. So the generating system will be designed in such a way that it will include both load as well as the losses. Also, by load flow analysis, we have all the information about the voltages, so the bus voltage magnitude will remain close to the rated value. The design will be such that the bus voltage magnitude will remain close to its rated value. Similarly, the generator will operate within the specified limits of the active and reactive power. By knowing all the values, we will operate the system in such a manner that the transmission line and the transformer will not be overloaded. The information of load flow is essential for analyzing the effective alternate plan for the system expansion to meet the increased load demand. That is, if we have suddenly the demand will increase, we will use the power flow analysis method to adjust the increased load demand. Similarly, the optimization problems in the power system in terms of losses or stability or in terms of security, these can all be analyzed using the power flow analysis method. Now, coming to the need of load flow study. By doing the load flow analysis, we will get help in a number of things. For example, in designing a power system, in planning a power system, in expansion of power system, or providing guidelines for optimum operation of the power system, and for providing guidelines for various power system studies. Now, coming to the procedure of load flow analysis method. While performing the load flow analysis method, first of all, we have to analyze the buses. What actually bus is, how many buses are there in a system. We will also learn about it in the next slides. First, we will understand the procedure to perform the load flow analysis. First of all, we have to find the voltages at every bus. After that, we have to obtain the power for optimum operation of the power system. After that, we have to study for various difficulties. For example, overloading of one or more transmission line, or overloading of generator, or loss of one or more transmission line, or shutdown of generators. After that, knowing all these details, we can perform the load flow analysis method. Steps to be followed in performing the load flow analysis method. First of all, we have to represent the given system in terms of its single line diagram. That is, we have to draw the single line diagram of that system. After that, we have to form the impedance diagram using the single line diagram. After that, we have to form the network equations, and then we have to solve those equations to get the required values. After that, knowing all the parameters, we can operate the system within the specified limits of power and voltage. Now, coming to the classification of buses. First of all, we should know what actually a bus is. Bus is actually a node at which many transmission lines, loads, or generators are connected. So at any node at which a transmission line or generator or a load is connected, that will be a bus. For the simplest system, we will have only two buses. That means, for example, as shown in the figure, we have just connected two generating stations by transmission line using two buses. That forms a true bus system. In the next figure, we have shown a 3-bus system. After that, I have shown a 4-bus system. The point here to be noted is that it's not necessary that each and every element should be connected to the bus. Means that it's not necessary that a bus should have all the 3 elements connected to it, that's transmission line, load, as well as generator. We can have a bus in which only transmission line and generator is connected. We can have a bus in which only transmission line and generator is connected. We can even have a bus in which only load is connected. Now, coming to the classification of buses. Now, we are all familiar that in any power system, we have only 4 quantities. That is active power, reactive power, voltage, and phase angle. So, buses are classified on basis of these. So, we have 4 quantities. When 2 quantities are known, we can get the information about the other 2 as well. So, the buses are classified into 3 categories. that is load bus, generator bus and slack bus. First, coming to the load bus. Load bus is also known as PQ bus because in load bus the active power and the reactive power are specified. So it's known as the PQ bus. Almost all the buses, 80% of the buses in the power system are load buses. So we have information about the active power and the reactive power. We know the two quantities. Rest two quantities we can calculate. That is, in load bus, P and Q are given. After performing the load flow analysis, we can get the information about the voltage and phase angle. Now coming to the generator bus. Generator bus is also known as the voltage controlled bus. In this bus, the two quantities that are specified are active power and the voltage. This bus comprises 10% of the buses in the power system. This bus is also known as the regulated bus. So in generator bus, active power and voltage are specified. After performing the load flow analysis, we can get the information about the reactive power and the phase angle. Now coming to the slack bus or swing bus. In the slack bus or swing bus, the two quantities that are specified are voltage and phase angle. After performing the load flow analysis, we will get the information about the active power and the reactive power. The point here to be noted is that we consider a generator bus, and after that one generator bus is selected as the slack bus. For slack bus, we consider the value of voltage as 1 plus J0 per units. So when we will be given any question, we will analyze the buses. After performing the analysis, we will see what information we are given. If for a particular bus we have been given the information about the active power and the voltage, so we'll consider that bus as the generator bus. If for some bus active power and reactive power both are specified, so we'll consider that bus as the load bus. All this is based on the analysis. Rest you can just check the table and you'll get the information. That's all for this lecture. Thank you. Stay connected for the further lectures.